Hi, my name's Todd Ferrante, and I am a dance photographer. As you can see in this picture, this is the kind of setup that I would use. I use off-camera flash a lot. I have, in this one, I've got a speed light mounted on this light stand, and I've got another light mounted on this one. And taking a picture that results in something like this. But occasionally, bad things happen, and you can knock over a light stand. And when that happens, as it happened to me recently, I used a speed light that had a hot shoe on it that would go into a Sony camera. And one of the things that about this Sony hot shoe design is that it has this little plastic shoe, which essentially just has these tiny little tabs on it. And if you side load these, this little tab will snap right off. And that's what happened to me recently on the Speedlight. And you can go online and you can see videos on how to replace this part with a replacement part with a new hot shoe on it. But those replacements cost about $20. And when you replace it, you end up right back with the same weak geometry that I had in the first place. If I mounted my speed lights on my camera to take pictures, then I might need to do that. But since I use off-camera flash on almost all of my photography using a radio transmitter mounted on the camera, I don't see any need to do that. So I decided to go ahead and replace this part or replace the broken part with an aluminum block that I could tap and thread right on the top of the light stand. So this video is going to show how I did that. So what I did was went into the inside of this part that gets removed, and you can see that there's a bunch of electrical components here, basically just connectors. And you can unscrew all these little screws and remove all of that hardware so that you have this plate with sort of this flat part here, and then there's a bump out right here that all this other stuff mounted to. And what I did, and this is what the inside looks like. What I did was I took some snippers, some flush cut nippers, and I went ahead and cut off that protuberance. Just cut it right off of there, so that the top of this surface ended up being flat, and then hit it with the file to get off of to get rid of all the little rough bits. And it turns out that bump that's there is about 1 1/8 inch square. So I went and got myself a piece of aluminum and laid out a 1 1/8 inch square on it, and then marked the center where I could drill and tap a 1/4 20 hole that I could that the light stand will go to. So this is drilling the hole where that's going to go, and then I used a 1/4 20 tap, chucked into a drill, and then power tapped that hole, uh, and then took some double-sided sticky tape and applied that to the aluminum so that it didn't come quite to the edges, and then placed the plastic part upside down on that piece of aluminum flush with the sides, and then stuck it down in place. And the reason I did that was so that I could then drill through holes into the aluminum of the proper size. That this is a tap drill for a number 440 screw, and you can drill through here and then tap these holes and then run a socket head cap screw down into the aluminum block. And in this case, went ahead and did one hole and drilled it and tapped it and installed the screw. And then that made it so that it was not going to move when it was just stuck on here with tape. And then I went ahead around the outside and did the other 4 screws. And so this is, you can see, this is the center hole that's been drilled and tapped for a 1/4 20. These are the 4 holes that were match drilled through the plastic down into the aluminum for the 440 socket head cap screws. At this point, all of these holes, this is everything I need to mount the block onto the plastic part and to mount the block onto the light stand. So now we can cut this out of the aluminum piece using the bandsaw. So that's what I'm doing here. And this is what it looks like when the part comes off. And then I took it over to the belt sander and cleaned up the corners and smoothed off the cut marks off the sides, and even rounded the bottom of the block just a little bit, so that when this is attached to the bottom of my speedlight and the speedlight is sitting in my camera bag, there weren't any sharp corners on the bottom that might wear a hole through the middle of the bag. So there is the block getting cleaned up, and then this is what it looks like when the block is attached to the plastic part with the socket head cap screws. And now, and this is what it looks like from the underside, and you can see that I rounded off these corners real nice. And then this is what it looks like when it's attached back to the bottom of the speedlight. And this block is about 5/8 of an inch thick. So there's lots of room for the top of the light stand to thread into this block without the threaded part going through here and impinging on the electronics inside. So there's just another view of what it looks like on the bottom, and that's what it looks like on the speedlight. Now this is the clamp that was originally on the light stand, and this clamp was clamped onto that the hot shoe on the bottom of the speedlight, and you can see that connection is just not super secure, especially when there was just those 2 tiny little plastic tabs on each side that this thing was clamping onto. This setup works a lot better with Canon speedlights, where the shoe mount is a metal plate. Then tightening down on this screw gives a real secure connection, but tightening this down on that plastic hot shoe connection was never very secure, and it didn't really surprise me that it ended up breaking in the end. So when you take that off of there, you can thread the light stand into the bottom of the speedlight, and then that's what it looks like when it's mounted up. And you can see that's just so much more of a secure connection. So that kind of wraps it up. It wasn't super hard to do. It would be trivial for the people that make these speedlights. Instead of making the speedlights with that crappy connector on there, they could very easily make a replacement part that you could take off that shoe and replace that with a nice solid threaded connection, and that would be a great option. It would even be worth paying the $20 if you could set aside that hot shoe connector, or that hot shoe plate, whatever you want to call it, for use when you want to use the speedlight on your camera. But then when you want to use it on a light stand, you could swap out the other one and get a good secure connection that's not going to break. That would be worth it if you could just pay for a replacement part for that. But I'm not aware that anything like that exists. It wouldn't be terribly difficult to design a part like that could be 3D printed and maybe have a metal insert that you could thread into. But even if it was plastic, if it was printed solid and you threaded into a solid plastic piece, even if those threads stripped out, you could just print another plastic part if you needed to. But for now, now that I've got this aluminum block on here, I won't have to do that. This should last forever. It's going to be rock solid. So that just about wraps up this video. Hopefully other people will see this, and you can do something similar, or maybe the manufacturer will see it and they'll come up with a better design.